To formally introduce myself, I am Ihtisham from Pakistan. Now I am doing joint PhD in Federal University of Minas Gerais and Silesian University of Technology, Poland. So my research focuses on spider venom-derived antimicrobial peptides. I'm testing these peptides against uropathogenic quinolone-resistant E. coli and its immobilization on urinary catheters to avoid biofilm formation and infections. So my research is associated with the urinary tract infections. So here I will speak something about its significance. It affects approximately 150 million people annually worldwide. And it's also one of the most important and most frequently isolated pathogen from urinary tract infections. And the graph you can see, it shows the commonly isolated pathogen from UTI. Acinetobacter, Escherichia, Enterococcus, Proteus, Enterobacter, Pseudomonas, Klebsiella, and E. coli. E. coli is one of the most highly isolated pathogen from these infections. So here is the transmissions ways. UTIs have the multiple ways. Pathogen can reach to UTIs through a lot of ways, like they can get to urinary tract by urethra. They can reach there by catheters, and they can also get by blood, like hematogenesis. So these are the virulence factors that increase the virulence and chronicity of these infections. Like they secrete some virulence factors like alpha hemolysin, femoral adhesion, polynephritis-associated pilus, and FEMH. So how these virulence factors assist this E. coli in causing infections, making biofilms, and then spread to the other part of the urinary tract. So first they invade the uroepithelium, they damage the uroepithelium to colonize, and then when they are able to got a favorable environment, they start making biofilms. And when they start making biofilms, they are protected from antimicrobial therapy, human immune system, and the other defense systems, so they are able to cause persisting infections. In the graph, you can see how initially first they attach, and when they get a favorable environment, they start colonizing, making biofilms, and then they disperse to the other parts of urinary tract. Now we will speak about the antimicrobial therapy. In recent years, as antimicrobial crisis, UTI is also one of the organs that's affected by the drug resistance. So here you see, in recent years, has seen declining in antimicrobial therapy effectiveness against pyelonephritis due to drug resistance. Since the emergence of drug resistant species, our immune system is not able to clear the infections, and almost all of the antibiotics, they reduce their efficacy. And the graph you can see, the antimicrobial resistance, this rate is from 2018 to 2022. You can see ampicillin, cefuroxime, ampicillin, ceftriaxone, ceftriaxime, imipenem, gentamicin, thenamidapine, ciprofloxacin, chloramphenicol, and nitrofurantoin. So you can see the antimicrobial resistance, that all of the antibiotics, they are losing their efficacy against these infections. And the second part, we will speak about the genetic factors, what are the mechanisms that drive these antibiotic resistance. In the graph 2, you can see the antimicrobial genes that drive antimicrobial resistance, like to aminoglycosides, ESBL extended spectrum, beta-lactamases, and the other fosfomycin, sulfonamide, and tetracyclines. Yes, genetic mutation, and yeah, also in the DNA, because a mutation in the quinolone-resistant determining regions where they're able to show resistance to quinolones antibiotics. Also, these bacteria is able to produce some toxins that able them to cause infect the or damage the other part of the urinary tract, like renal damage that is done by hemolyzing. Also, it causes septicemia. Also, E. coli is responsible for the 70 to 80% of pyelonephritis. Initially, pathogens reach to UTI, but when they get favorable environment, they easily reach to the upper part of kidney and cause one of the most important infections called pyelonephritis. And also, in the 2 decades, the incidence of the pyelonephritis has been doubled. Here is a graphical representation. Initially, the infection causes in the lower urinary tract, and when they make biofilms, the antimicrobial therapy is low. They are able to shift to the other part of the kidney, upper part of the urinary tract. So as the antimicrobial antibiotics have reduced their efficacy, so we try to test antimicrobial peptides against them. These are the ideal candidate for the new antibiotics. This has a lot of other properties beside antimicrobial, like they are immunoregulating, they also cause angiogenesis, and also have anti-tumor activity. And also one of the other property that make peptides ideal candidate, they have a membrane disruption. Also, they have other intracellular site inside cell, like they disrupt the ribosomes, and also they disintegrate the chromosomes. So here you can see how inside they kill the bacteria. Initially, once they attach to any membrane peptides and avoid the bacterial adhesion. And then if they go inside, they produce ROS, with which it has other functions, like they interfere with the protein synthesis, also with the enzymatic activity, and also chromosome condensation. So this is a short objective of my study to test peptides by MIC, MBC, its antibiofilm effects, its toxicity, in vivo study, and in silico, its docking, and admit analysis. These are the peptides initially selected for this study: LyeTx I, LyeTx IB, LyeTx MN, LyeTx mnΔK. This peptide is one of the most effective, and also it's balanced between like having high antimicrobial activity and minimum cytotoxicity. So these are the short methodology: isolation, identification of UPECs, and analysis of antimicrobial resistant pattern, and also the investigation of antimicrobial mechanisms. And then the peptides MIC, MBC, antibiofilm assays, viability testing through MTT assay, and then its evaluation in vivo studies, and also at the end, antimicrobial efficacy in vivo. And we also try to do some computational studies to do its interactions with one of the most important adhesins, and then adminalize. So here is the initial data of the pathogens. You can see the antibiotics. The MSC of those antibiotics has been considerably increased. Even they are increased than our peptides. So it shows the resistance toward these antimicrobial peptides. We also check the resistance mechanism, like quinolone resistance, ESBL, extended spectrum, beta-lactamases, and carbaminopeases. None of the isolate was carbaminopease positive, but 5 isolate were resistant to extended spectral beta-lactamases. Here is the MIC of all of the peptides. LyeTx mnΔK was one of the most important peptides, having minimum MIC and minimum MBC. So we try to use this antibiotic in our study. At the end of the right side, we use control colistin and meropenem. These two antibiotics are one of the most effective antibiotics against these pathogens. So we try to include them as a control. So this is a general graphical representation of the of our peptides. As you see, LyeTx I mnΔK was one of the most effective. After MIC and MBC, we check its antibiofilm effects through check inhibitory effects biofilm mass and the viability. So, and the biomass quantification, we did not get any significant results, but through viability assays, we analyzed it. We found that this peptide considerably decreased the metabolic activity of the pathogens. Here is the in silico studies. Initially, we predicted or the structure of peptide by LyeTx web servers and visualized by PyMol. And then we use Ramachandran plot to depict, to validate the structure of the peptides, whether it is good or not, whether it is good for the studies or not. These are the structure of two proteins, FemH and PepG, both of the adhesines proteins of the E. coli that is used in its pathogenesis. FemH especially uses in kidney infection, pyelonephritis, when they try to attach initially cause infection. So here you see the first we check with the PepG. You can see our peptide is able to bind easily with the PepG protein, making hydrogen bonds with tyrosine, and also it was able to do hydrophobic interactions with lysine and aspartame. It's also, our peptide was able to interact with the FemH proteins, adhesines of the E. coli. That is most important in the infection of the pyelonephritis. PepG also, the E. coli is able to cause on medical implants infection like catheter. We did some admin analysis. I think this is the first study who did admin analysis, because most of the research doing in vivo studies. All of the parameters and the pharmacokinetic properties were and the medium ranges. We compare our results with one of the recent study published in Frontier Molecular Biosciences. Our parameters were almost similar with that study. Recently, we did in vivo toxicity. We use 3 different concentration of peptides, 1 mg, 5 mg, and 10 mg. We introduce these peptides through subcutaneous way. On the first day, right after the introduction, 1 mg, 5 mg, these animals were safe, but with the animal with 10 mg, initially they get depressed, but after 1 hour they were relaxed. Right now, these are some ongoing experiments. We are doing to see these peptides able to prevent biofilms on urinary catheters or not. And then we will go for the antimicrobial efficacy of the MPs in the animals. This is the future direction. After completing this, we will go to conjugate these peptides with polymers like PLGA. So then we can able to immobilize on the surface of catheters. PLGA we are using to optimize the human immune responses. So initially we will conjugate it with these polymers, then we immobilize on the catheter surface. And the modified catheter surface, we will do physiochemical characterization, antimicrobial activities in vitro, and antimicrobial activities in vivo. Yeah, this was the result from the previous conference that held in November. I presented my research in 2 conferences. One was computational personalized medicine in Poland, and the other recently I presented in France in June. Since I started my PhD, all the time I was stuck in visa issues, get Polish visa, get Brazilian visa, so I was not able to pursue my research on time, but I was able to publish some good review papers. The first paper is about antimicrobial polymers. The other is antimicrobial peptides, published in Journal of Industrial Microbiology and Biotechnology. And the last 2 these are published in Elsewhere, Journal Applied Surface Science and Journal of Infection and Public Health. These are some minor achievements. PhD scholarship from Silesian University of Technology, Poland, and then here postgraduate development program, strategic partnership. And from Poland University, I was able to honor 2 other awards, grant for highly scored publication and best PhD student scholarship between 2023 to 2024. These are the references. Yeah, these are the thanks to my supervision. One of my professors sitting here, Professor Maria Elena, she was the one who gave us peptides. And my other professor supervisor include Dr. William Gustavo, Professor Rafael Pentuvera, and my Polish supervisor, Professor Dr. Katarzyna Krukowicz. These are some agencies that provided financial support. And also I want to acknowledge these, like Brazilian Society of Technology, Silesian University of Technology, Santa Casa Hospital, CNPq, CABS, and FEVIMIC. Yeah, that's it from my side.
Thank you for your nice presentation. Questions? I have one question. About the in vivo results, you tested different doses of the peptides. Have you compared it with some other drug already in the market that has the same antimicrobial effect?
I think the drugs that are already in marketed, I hope they are passed through from these trials, but I never compared with my results with these any available drug antibiotics. Like recently, the two most antibiotics that are most effective, like meropenem and colistin, but I never compare my results.
Okay.
In terms of potency, do you are able to compare your peptides to other peptides described in literature?
I don't know too much about other peptides, but the peptide that I'm using, like this has been compared already with the same spider venom derived peptides like LyeTx I, LyeTx I-B, and this was the one with the high potency and minimum cytotoxicity and minimum side effects. But I never compare with the other peptides isolated from the other sources or synthetic peptides. But this is already compared from the other analogs.
Okay, thank you.
Because in this case, Mariana, our objective was to choose the best between a family of peptides from Lycosa. So it seems that it's a small peptide that is synthesized. It's a reduction of a natural toxin from Lycosa, LyeTx I, that was isolated by a student in 2010. And now it's a reduced peptide. And it seems that it gives the better result. But I think I didn't see the presentation before. I think Ihtisham may give more focus because it's so much results. Thank you.
Any other question? Well, then we will call our last speaker, Marcus Vinicius Buri. Marcus will give his lecture online. Are you here?